We all know how powerful AI has become. I mean, it can write code, it can generate incredible art, it can answer questions in a blink, but it has this surprising blind spot. If you give it a really long, dense document, think a legal contract or a heavy scientific paper, it just kind of struggles. So today, we're going to dive into a pretty radical new way to fix that by building what is basically a custom-made digital obstacle course for AI.
So let's start with the big question, right? Why is it that these super advanced models that can gobble up so much data just can't seem to connect the dots when they're reading something long? This isn't just a minor bug. It's a huge bottleneck that's holding AI back from solving some really complex, real-world problems.
And this is where it gets really interesting. AIs are fantastic at finding stuff. You could ask one to find a specific sentence in a 1,000-page book. That's the ultimate needle in a haystack problem, and it'll probably find it. But what if you ask it to explain what the whole haystack means? To pull ideas from the beginning, the middle, and the end and put them together? Yeah, that's where the wheels fall off. They can find the facts, but connecting them is the hard part.
And this problem actually has a name in the field. It's called long context reasoning. And believe me, it's a major focus for AI researchers. Figuring this out isn't just about making AI a little bit smarter, it's about unlocking a whole new level of capability for things like law, medicine, and scientific discovery.
So how do you teach an AI a skill it just doesn't have? Well, a team of researchers came up with this brilliant solution called LOONGRL. And the heart of it is this ingenious method they named KeyChain. And really, the best way to think about it is as a custom-built, super difficult digital obstacle course designed for one thing: to teach an AI how to reason. Now, this whole obstacle course is built using something called synthetic data. And I know what that sounds like, but hold on. We are not talking about fake news or made-up facts. In this context, synthetic data is more like a carefully engineered puzzle. The researchers take real information and then twist it and structure it into an exercise that is so ridiculously hard, it forces the AI to invent brand new ways of solving problems.
So how does this crazy obstacle course actually work? This is the magic of the KeyChain method. So first, they start with a pretty straightforward question, something that needs a few steps of logic. Then, and this is key, they bury that question and its answer inside a gigantic wall of text, like 16,000 tokens of just distracting, irrelevant information. But here's the brilliant part. They hide the real question behind a cryptic treasure hunt. They create a chain of these unique digital keys, and the AI only gets the very first one. It has to follow this trail just to figure out what it's even supposed to be doing.
And this right here, this gives you a real sense of just how tough this is. The AI isn't asked, what is X? It's given this long, random-looking string of characters and basically told, okay, your mission starts here. Go follow this trail of digital breadcrumbs, find the real question, and then you can try to answer it. It's an incredibly difficult problem, and that is completely by design.
So what happens when you put an AI through this brutal digital boot camp? Well, the result wasn't just a slightly better model. It was a genuine aha moment. The AI didn't just get better at solving the puzzle, it fundamentally changed how it thinks. It came up with a whole new strategy for tackling complex problems. This slide is the absolute core of the breakthrough. Before this training, the AI's thought process was, well, a mess. It would try to find information and reason about it at the same time, all tangled up, which led to a ton of confusion and mistakes. But after going through the obstacle course, something incredible happened. A clear, structured, and honestly a very human-like pattern emerged. The AI learned to first plan its approach, then retrieve the info it needed, then reason about that info, and finally recheck its own work. It's just a much smarter, more reliable way to think.
But here's the truly mind-blowing part. The researchers didn't program the AI to do this. They didn't write a rule that said, Step 1, plan. Step 2, retrieve. No. This advanced four-step reasoning process was an emergent capability. The AI literally discovered this superior strategy all by itself, simply because it was the best way to beat the incredibly hard puzzles the KeyChain obstacle course kept throwing at it.
Okay, so the AI learned a whole new way to think. That's fascinating, but what does it actually mean in the real world? What's the payoff? Well, it turns out the payoff was huge. This new skill led to some really dramatic, measurable improvements. Just look at that number. For one model, the QN 7 billion parameter model, there was a staggering 23.5% absolute jump in accuracy on these long document tasks. I mean, that's not a small improvement. That is a massive leap forward. And what's really amazing is how this new ability lets smaller models punch way, way above their weight class.
This chart shows the LOONGRL trained 14 billion parameter model, and look at its score, 74.2. That is right on the heels of industry giants like O3 Mini and DeepSeek R1, models that are way bigger. It's a total underdog story.
Oh, and remember that whole needle in a haystack problem we started with? Well, this training didn't just improve reasoning, it also perfected the model's basic retrieval skills. It scored a perfect 100% on that test, a benchmark where the original model actually stumbled.
So let's just quickly wrap up the key breakthroughs here. First, generalization. Models trained on these 16,000 token puzzles could then turn around and solve problems in documents 8 times longer, up to 128,000 tokens. Second, efficiency. Training on huge documents is insanely expensive and slow. This method gets around that completely. And finally, preservation. The model got this new superpower without forgetting its old tricks. Its skills in other important areas, like math, stayed just as sharp as before.
All of this brings us to one final, really powerful question. By creating these incredibly difficult synthetic challenges, we're not just making AI better at a task, we're actually teaching it how to think in a more structured, logical way. So if we can teach an AI to reason more like a human, what kind of massive problems are we going to solve next? Think about it. An AI that could truly understand a complex legal case or synthesize decades of medical research to find a new cure. The possibilities are really just beginning to open up.